there! Let's talk about expressing geometric properties with equations, starting off with circles. Now, you see the circle, let's talk about some of its properties. So let's say this is the center of a circle, and we have a line. Well, this line is called the diameter because it is the full length of the circle's longest width. And this would be diameter. And half a diameter, which would be just this part, everything from either the left side or the right side, that would be the radius. Now, some other parts are chords, which are extending from one point of the circle to another point. And this would be a chord. And another part is a sector, which starts from the center and goes off to another point, and it includes the radius. That would be a sector. So we have sectors, radiuses, diameter, chord. What's next? Well, there's also an arc, which is the distance of the outer part of the circle for a sector. That's called an arc, and the whole distance of an arc is called a circumference. Alright, now that we know that a little better, let's talk about how to find the formula of a circle. So for this circle here, the formula would be, to find the equation of the circle, would be x minus h squared plus y minus k squared equals r squared. R stands for the radius, and h and k together stand for the points of origin, the center of the circle. And here, conveniently, the center is 0, 0, and the radius would be the length from the center of the origin to the edge, which would be the radius, and that's 1. So let's plug it in here. If hk equals 0, 0, x squared plus y squared equals 1 squared. And that's our basic formula. That's the simplest formula you can get here. Let's move on. So for the reverse, if we wanted to find the radius or the center of an equation, we can complete the square. We can just factor this out. So let's say x squared minus 4x plus 4 plus y squared minus 6y plus 9 equals 9. If we reduce this, we would get x squared, 4x plus 4 plus y squared minus 6y plus 9 equals 9, and we would get 13, 9, so negative 4 x squared minus 4x plus y squared minus 6y equals negative 5. I'm sorry, negative 4. And what we do is complete the square here. So to complete the square, we would find what makes the square complete. So for here, we would have plus 4, and here we would have plus 9, because 4 and 6 are 2 and 3 respectively. So we would have to add plus 4 and plus 9. So x minus 2 squared plus y minus 3 squared equals 9. And that's how you decrypt the formula and rewrite it. But we know that the vertex, or the center, would be 2 and 3, because we just simply do the reverse of each to get the center. And the radius would be what it's equal to and the square root of it. So that would be 3. So going back to circles, let's talk about the similarity of circles. Well, circles are all similar to each other. Well, why is that? It's because they all start at a certain point, at the center of a circle. And every circle starts in the same center, but it's shifted somewhere, or it's moved up or down, upside down, but you can't tell because it's a circle, of course. But they all have a center, and the only reason why it gets bigger is because it's dilated by a certain factor. So it doesn't always have to be a whole number, but it is dilated by a certain factor, decreased, increased, and that's how they're all similar to each other. So let's find the area of a sector of this circle. We have all the given information, and the formula would be area of the sector equals n, which, let's say n, which is the value of the central angle, over 360 for degrees, times pi r squared. The pi r squared is area, and the n over 360 just shows how much of the angle out of 360. So let's plug it in. 100 over 360 times pi 8 squared. And this would be equal to 55.85. Now, next one. It's basically what this is telling us is the space taken up by this space right here. The next thing we're going to cover is arc length of a circle. Since we want it in degrees, let's say the arc length, arc equals the angle, let's call it n, times pi over 180 times the radius. Let's plug it in here. 100 times pi over 180 times 8. And this would be equal to 13.96 degrees. And this is telling us how much this distance is. Some equations you'll have to know are the equations for ellipses, which is x minus h squared over a squared plus y minus k squared over bx equals 1. And this is for an ellipse, which looks kind of like an oval. And the next one is a hyperbola, which is very similar, except for one important difference. This would be hyperbola, which looks more like this on a plane. And the difference is that these two are switched, and that makes a key difference. It shifts, it rotates the whole thing onto its side. So, after knowing these, the other couple formulas you'll have to know are the distance formula, which is d equals the square root of x2 minus x1 squared plus y squared minus y1 squared. This is for finding the difference between 2 points not on a straight line. So let's say that point and this point, and you have to find the distance by just connecting a line and using the distance formula. Some other ones include, let's say, the slope formula, that's a classic, which is y2 minus y1, x2 minus x1. And another really common one from algebra is midpoint formula, which is one plus x2 over 2, y1 plus y2 over 2. And this equation creates these 2 points, which are normally x and y, for the midpoint between 2 points. Let's say that point and that point, and you want to find the middle. So you'd use this formula to find the middle, and this is just pretty much taking the average. And that's all the formulas you'll have to know for geometry. You can apply these problems into so many different ways. We can use them in perimeters, polygons, trigonometry, graphing, and so many other ways. So thank you for watching, and this has been provided to you by SATFreepractice.com.